Any questions?
Yeah, anyway.
Yes.
This, or with some of these images. Okay. Is there any way we can have this like large?
Yes. Send me an email.
Gosh.
I have one quick question. When is the 9 and 10 chapter set or master set due? And are they both due at the same time, or is 9 due like this Thursday? Or what are we doing with that?
They're both due Thursday of next week.
We won't be here, I don't think.
That keeps you from turning stuff in? Think of it. You need to clean up or something, whatever you do on Thanksgiving Day, and say, no, sorry, I have physics to do. You just, sorry, uncle, I can't spend any time with you. For me, that would be a bonus, but I don't know about you. They're not assigned yet. Now that Gigi's here, we can begin. Other questions?
What's your favorite unit in 151?
The favorite units?
Like a favorite chapter?
Jack.
He hates all
I mean,
of
to
it.
me, chapter 4 is the fundamental to all of it.
Okay.
I mean, chapters 2 and 3 might be considered fundamental, but that's just math, not really physics. All right. In the absence of questions of which I'm aware. What does torque equal? Or why don't we just start out, less of a math question, what is torque?
The singer or the physics thing?
Singer?
Well, I looked up or no, I think it was a singer.
DJ Mabuko.
Yep.
I don't use that word for torque because of any singing and stuff. Okay. An influence which might cause angular acceleration. It's basically, like a force is a push or pull, torque is a twist or rotation turn. All right, now on the math sheet. We got two equations. I'll take either one. I was thinking we talked about what torque is. There we go, there's one of them. So, what is I? So again,
Moment of inertia.
yes, there's a big difference there. And alpha?
Angular acceleration.
Yes, all right. And this torque in this case is the total torque. What about an individual torque? I mean, if this is total, it means I'm adding up a bunch of individual ones, so how would I find an individual torque? So that's the total. And it's helpful if there's only one torque, because then we get two equations we can set equal to each other. I'll put to here. Are we done the closing of the door bit? Or the? Really nice if the door opened inwards. That door opened inwards, but it doesn't. Have we talked about the closing of the door? No. Then let's talk about the closing of the door. So, Or that's in the way. All right, the closing of the door. All right, so what is the most efficient way to close the door?
Push one.
That didn't work.
To push inwards.
Inwards,
Clockwise.
Push clockwise. He said.
clockwise?
Okay.
You're gonna throw in more descriptive than just clockwise? Clockwise would be that way?
My clockwise.
Your clockwise.
Yes, that's this way.
So from your point of view, clockwise goes around like that, so. Like that? Pardon?
Would you pull it?
Rotationally, that way.
Rotationally that way.
Almost did it.
How about All right, so first off, let's get some language down. When we talked about clockwise, counterclockwise, we can do better than that. The wheel. Do Anfield, I'm pretty sure we talked about that.
Yeah.
What's the direction of the rotation?
That way.
Okay, back of the room. For those who have forgotten it or were absent that particular day, you got an axle that's running basically from front to back. Thumb X is the axle, right hand, and then you curl your fingers in the direction of the rotation. And so thumb points backwards, as opposed to that way. That would be a rotation pointing towards the front of the room. All right. Well, there was one thing that has been identified as part of torque, and that is I have to push somewhere. So force is indeed part of it. It will eventually show up in the equation. But there is another critical piece to it.
Displacement. Like it has to move only a certain amount.
That would be a result of not the cause of torque, but a result of the torque.
The hinge.
What about the hinge?
How much is force it takes to, I guess, turn the hinge?
We're thinking of hinges differently. The hinge, I'm picturing as the axis of rotation. The hinge won't move. I hope it doesn't move. I guess that means the door's falling off the hinges. Or the hinge is being ripped out of the door frame.
So the hinge, if the hinge is the axis of rotation, then, but it's, I guess it's limited now, because the door can't go.
There is a maximum distance the door can go in either direction,
Right.
if the door is made properly. I guess not true if it's a revolving door. Let's assume not revolving door. Let's just eliminate that.
That's not a real door.
There we go. It's like a movable wall.
Does it have to do something, I'm just going on a limb, just the radius of like the door to the hinge? Yes or no?
It depends on what you mean by that. So my first gut was say yes, but
Kind
The radius from the hinge of the door from the hinge to the outside, or to the edge of the door.
You're real close.
Is it the radius from the hinge to where you push,
From the hinge,
to where you push on it?
that is the key. All right, so we have another important piece there. Called the moment arm. Sometimes referred to as lever arm. That will be represented by an R. It's a vector, that's a force. There's one last piece. Think about the first example. When Ibrahim talked about you push on the door, and I pushed on the door.
You have to establish a direction.
More specifically, relative direction between these two vectors. These are the components, relative direction of R and F. Now, let's get into a little bit of definitions. Moment arm is a vector, as is indicated right there. The direction from the axis of rotation to where force is applied. But if I've got a door here with a hinge, if I push on it this way, what's the door gonna do?
Stay still.
All right, so just being far away from it and applying force is not enough. There's one other aspect. When we talk about the relative direction, in this case, the relative direction is 180 degrees, because one's going up, one's going down. So we need somehow a function that will be equal to 0 if the relative direction is 180 degrees. So some function of that angle equals is what we're looking for. So that function of 180 degrees equals 0. That's one piece that we need. Matter of fact, if I pull on it, so if I reverse the force and I pull on it, that's not gonna help much either. It's like grabbing the doorknobs and just pulling away from the hinge. So the function, whatever this function is of 0 degrees must also equal 0. So what function do, presumably some of you know, where that's the case?
Is this a unit circle thing?
It is a unit circle thing.
Where do we have, is this one of the things where you have to set like theta is less than 180 but greater than 0? You have to write that out or no?
No, we don't have to write that out.
Is it the sine of theta?
Say it again?
Sine of theta?
Yes, sine of theta. So, whatever this angle is theta, there's a sine of theta that shows up in it. So that would be theta and sine of theta. And the math people, of course, came up with a shorthand notation to represent all the stuff that we just talked about, R cross F. We've talked about dot products. This is the other type of multiplication.
What's the circle with a string on it?
So this,
No, the thing right next to the R I have.
that
Left 2.
of,
Okay.
that's an F there. We've been together for months.
Got it.
All right. First off, it is a cross product because the cross is used as the symbol for multiplication here, as opposed to the dot product, which uses a dot. The magnitude of the torque, well, let's do it slightly differently. If I have a vector A and a vector B, and I do a cross product of A cross B, the magnitude of that is, well, I can break B up into components, or A up into components, whichever one seems more appropriate. This angle here is theta. I can break B up into components where this length right here, and we will of course go for the study of visual effects. This length right here would be B cosine of theta. This would be B sine of theta. The sine of theta shows up in the perpendicular component. So a cross product is multiplying perpendicular components, whereas a dot product multiplies parallel. So we have a cross product there. Another way that you can remember it is that the cross is perpendicular. They're two big perpendicular line segments. Despite the way that I might draw it sometime, that's sort of a right angle right there. So the magnitude of A cross B is the magnitude of A times the magnitude of B times the sine of the angle between them.
I don't know if this matters, but is that that segment outside of the triangle? Or is it the
This A
whole
right
line?
here?
Yeah.
That A, yeah, I should have started with the other colors earlier.
Or is that like the whole bottom line?
It's the whole, A is a vector that goes from here to here.
Okay.
All right. The direction of the cross product, and I'm still feeling like we covered this, but then again, maybe it was another group. Put your hand in the direction of the first vector. A is pointing that way. I got 360 degrees right hand. The 360 degrees of freedom there. I curl my fingers towards the second vector. My thumb points outwards towards the back of the room. And so A cross B, the direction of A cross B would be a vector pointing that way. Since we are now dealing with 3 dimensions, we need a way of representing that. And I have more confidence that we've done this before. But if I hat, J hat, coming out of the board, be K hat, and out of the board, or that direction, is represented by a dot. Into the board, represented by arrow is the memory trick. Yeah, the cross. So into the board, or into the surface, out of the surface. And again, arrows coming at you, you see the point. Going away from you, you see feathers.
It would really work for a bullet, would it?
That's why we don't use the bullet as the memory trick. And I hat cross J hat. Well, based upon the right hand rule I just gave you, I hat cross J hat.
Is K hat.
Yes. J hat cross K hat.
Is
Also,
I hat.
Also, okay. Just going away from me.
Wait, J hat cross K hat? Or do you do it your phone?
I was doing J hat. I hat.
Oh yeah, J hat, I hat, cross I hat would be into the board. So commutative property does not apply. It does matter the order in which you multiply. And from a physical point of view, R cross F versus F cross R, one would have the door opening, the other would have the door closing. All right, so I have done at least some of that. So just plug and chug. I've got a rod here with axis of rotation right here. Axis of rotation. I apply a force here of 3 newtons, a distance of 4 meters away. I hat, J hat, K hat. torque. The torque on this rod, about this point from the 3 Newton force, would be, let's see, R is a vector going that way, from the axis of symmetry, the axis of rotation to where the force is applied, is 4 meters, actually, let's put in the intermediate step, R cross F, 4 meters, negative I hat cross the force, which is 3 newtons J hat. There are 3 major ways of finding the direction. First off, they're already perpendicular to each other. What's the angle between them?
180, I mean 90.
Yeah, sine of 90 degrees.
1.
So the magnitude is just going to be 12 Newton meters. The direction, we can do the direction of, we have negative I hat cross J hat. Well, I cross J is K. We just talked about that. Also, I hat to the right, J hat up, so I hat, J hat, K. Thumb points out, which is the K hat direction. So it's going to be negative K hat. Also, if we think about this, if I apply a force right here, and that's the axis of rotation, which way is this thing going to rotate? From a clockwise, counterclockwise point of view, from where we're sitting, which way is it going to rotate?
Clockwise.
And clockwise, thumb points into the board, which is negative K hat. And the other way is, I draw them tail to tail, there's my R hat, and there's my force, sorry, not R hat. My moment arm, my force, R cross F, hand in the direction of the first vector, fingers scroll to the second vector, thumb points into the board again.
So, quick question. Why do we use negative I hat times or cross J hat?
I have the negative here, so it depends on what I want to do with that, but the moment arm is from the axis of rotation to where the force is applied, it's pointing in that direction.
Okay, and we just call
And that's where the negative comes from.
Okay.